All right, welcome to this last day, 5.3. It's actually 5.3C, not B. Power reducing and half angle review. We may not do the review part, but we will do the power reducing. There are 3 questions. Go ahead and do those. It just take you a minute. Pause your video. There should be the answers to all 3 of these. Keep in mind, cosecant functions are just the peaks and valleys of the sine functions. So they can go from negative infinity to 2 in this case, and from 2 to positive infinity because your amplitude is 2. Principal values for sine of x are negative pi over 2 to pi over 2 inclusive. And then the reference angle for 7 pi over 8 is just pi over 8. All right, looking at this idea that we're going to talk about here, power reducing formulas. In order to derive these formulas, you're going to use cosine 2x formulas and then solve for the sine squared and the cosine squareds. So in this first one, we're trying to get sine squared by itself, which means we're first going to take cosine of 2x and we're going to subtract 1. Then we're going to need to divide by negative 2. So in the next step here, we're going to say cosine of 2x minus 1. We're dividing that by negative 2. And we're going to end up with something that says sine, sorry, I forgot my squared here. And so now I'm going to rewrite this sine squared x. It's going to equal, in this case, we're going to distribute the negative through the top here. So we're going to get 1 minus cosine of 2x over 2. That's going to be the first one right there. And then the second one is same idea here. We're going to get cosine squared by itself. So we're going to add 1 here. So we get cosine of 2x plus 1 is equal to 2 cosine squared x. Then we're going to divide by 2 here. So cosine of 2x plus 1 over 2 is equal to cosine squared x. And then we're going to just turn this one around so it kind of looks like the last one we did. This is 1 plus cosine of 2x over 2. That would be our cosine squared function. And then just like with most of the ones that we do, tangent is sine over cosine. So we're going to take the sine function, which is 1 minus cosine of 2x over 2. And we're going to divide that by the cosine function, which means we're really going to invert and multiply. So we're going to get 2 over, this is 1 plus cosine of 2x. So we get an equation here that says that tangent squared x is equal to 1 minus cosine 2x over 1 plus cosine 2x. Now, that's our last of the 3 functions that we're going to talk about. We're going to be using these to what we'd call reduce our power. Power reducing formulas are used in calculus in order to explore the rate of change over time. It is a way of rewriting a trig expression so that the power is smaller, therefore reducing the power. So number 1 is saying write an equivalent expression for sine of 4x that does not contain a power of a trig function greater than 1. So we're starting out with sine 4x, and that's really what we want to do here. We want to write this thing so that we don't have those, that we have gotten rid of all of our degrees that are bigger than 1. That's how we want to look at this. So now I'm not going to lie to you. There's a little bit of math that's going to be required to do a power reducing. So just keep that in mind when we go through this. So I'm going to start with the basic idea, sine of 4 to x. So this is really what we want to start with. And then I've got to figure out a way to write this so that I can start using these formulas up here, sine squared, cosine squared, or tangent squared, to get to where I'm reducing things. And looking at them, the only one really is sine squared. So realistically, I need to start by this understanding that if I say sine squared of squared, that's the same as saying sine of 4x. So what does that do for me? Well, it allows me then to exchange the equation, 1 minus cosine of 2x over 2, and we're squaring all of that. Now, I realize we still have the square we got to deal with, and we'll deal with it in just a moment and kind of come to that idea of what's actually going to happen here. Well, if I'm going to square this, well, that really means take 1 minus cosine 2x, write it twice, right? Because that's basically what we're looking at. And then we're going to take 2 and we're going to square that at the bottom and make a 4 out of that. Now, the obvious thing to do here, distribute. So we have 1. We're going to end up having a minus cosine 2x and a minus cosine 2x, which gives us a minus 2 cosine of 2x. And then we're going to have these two, which means we're going to have a plus. We're going to have a cosine squared of 2x. And all of this is going to be over 4. Now, I realize we still have a squared term, but we've simplified some of it to where we don't have those squared terms anymore. Okay, so we've got to keep that in mind as we go through this. That's our goal, is to just keep whittling it down. We can also take this thing and kind of break it into pieces. So the first part of this is going to say 1/4, 1 over 4, minus. This is going to be 2 cosine of 2x over 4, which I'm going to be able to reduce down here, and then plus. And then this part's going to say cosine squared of 2x over 4. So that's really what we're at this point. Now I'm going to look to simplify this a little bit and hopefully reduce it a little more, because I got to get rid of the squared in that last term. So I'm going to have 1/4. I'm going to have minus. I'm going to take 2's out of here, so I get cosine 2, or double angle cosine of that over 2. And then I've got a plus here, and now I've got to figure out what can I do with this thing? How do I eliminate this? Well, I'm going to use a cosine now. I used a sine up here to get rid of this one, and now I'm simply going to use a cosine to get rid of this one. It's going to say the following: 1 plus, this is going to be cosine. Now, here's the part that's going to change a little. Up here, we went from the sine squared x right there to this thing, where it says cosine of 2 and then x. But in this case, what's different here is that this right here, and let me make it a different color, this is really our x right here. And so you've got to understand, this is going to say cosine 2x again, but it's going to be 2 times x. And in this problem, our x is actually 2x, which means we're going to be saying the following. This is cosine of 2 times 2x. Hopefully you understand that part of it, because this is the kind of the part that you got to be able to do. And all of that is over 2, because that's still part of the equation, which all of this is still over 4, because that's what was down here, was a 4. I'm going to continue on. This is going to go 1 over 4. This is going to be minus. This is cosine of 2x over 2. And then plus. And now I've got to kind of whittle this all down. This is going to be 1 plus cosine of 4x over 8. Now I'm looking at this thing and I'm realizing, all right, well, I've got a little more work to do, because this is still not really a single fraction. We have a plus in there, and we got to get rid of this. So this is going to be 1/4. This is going to be minus cosine of 2x over 2. It's going to be plus 1/8, because I can take that out, plus this is going to be cosine of 4x. All of that is over 8. And now I have these two fractions. I need to add them together. Well, that's going to be, if I change this to an 8, we're going to have 2/8. And then we're going to say plus 1/8, and then minus cosine 2x over 2 plus, this is cosine of 4x over 8. And now I can simplify this to its final answer. This is going to be 3 over 8. is going to be minus, this is going to be cosine of 2x over 2 plus this is going to be cosine of 4x over 8. Now, that is definitely not simpler than sine, sine x to the fourth, however you want to say that, all of it to the fourth power. But it is a situation where once we know what x's are, we can just plug them in, and these are fairly quick, easy fractions to deal with to combine them to get your answer. We have gotten rid of our degrees of 2 or higher. All we have left are single degrees. We have a double angle part here, and we've got a double angle on this one, but that's basically the work that you go through to solve this. I know this is a lot of work. I told you that up front. You just got to focus and stay one step at a time. I guarantee you, the more times you try to eliminate steps, the worse it's going to be for you. So please don't eliminate your steps. Follow them through. Right, now that we're warmed up, let's take a look at the next one. Same idea. We've got a fourth degree here. We got to get rid of that fourth degree, get it down to something that's not fourth degree. So we're going to start with this process. It's kind of the same starting point here. You're going to start with the following. You're going to say 8. Let's do this in a different color just so we don't have all green. Let's go 8. This is going to say cosine squared x, and all of that is being squared. That's where we're going to start. And so we're going to say it's 8 times. This is going to be 1 plus cosine of 2x, all of that is over 2, and we are squaring that. So we took one of the formulas from that front page and we substituted in for the squared. And now we're going to keep going through this thing. I'm going to push the square through, so I'm going to have 8. I'm going to have this whole top part here, which is going to be 1 plus cosine of 2x. We're going to square that. And then at the bottom, we're going to square 2, which makes 4. Everybody hopefully is okay there. Now, I want to simplify this thing down a little bit. So I'm going to divide the 4 out of the 8 and make this a 2, because it's just a fraction times a fraction. Once I've done that, I now have something that says 2 times 1 plus cosine 2x, and we're squaring all of that. Now, what is it we want to do next? Well, the obvious thing is to multiply this thing out. This is going to be 2. We're going to have 1 plus cosine 2x, and we're going to multiply it by itself. So we're going to end up with 1 times 1, that's 1. We're going to have plus, we're going to have a cosine 2x and a cosine 2x. So 2 cosine 2x, whoops, I'm not done, plus we have a cosine 2x and a cosine 2x, so this is cosine squared of 2x. And then I'm going to multiply the 2 through all of this, and then try to kind of simplify it down as we go. So hopefully we're seeing that that's the case here. I'm going to multiply the 2 in here. We get 2. This is going to be plus 4 of cosine 2x, and then plus, and now I've got to fix this last part here. It's going to be 2 times. Remember the last time we took this thing and we moved it kind of to the outside of the cosine, right? We did that. So hopefully you guys remember that from that previous example. Let me continue on lower because I don't want to, I'm going to rewrite this down here. I just don't want to run out of room. So this was 2 plus 4. This is cosine of 2x, and then plus, and we're, like I said, we're distributing the 2 through, and then we have to move this part right here. So I'm going to write over here. You don't necessarily need to write this part of it, but it would really just be the same as saying cosine of 2x, and we're squaring that, which it's the same idea here, but cosine squared of x, keep in mind this is what the formula said, cosine squared of x. So either way, it's not going to be a big deal here. I'm going to just erase this because I wrote it down at the bottom. So I'm going to continue on here. This is going to say 1. Since it's a cosine, it's plus, so 1 plus cosine of 2 times that 2x we had, and all that is divided by 2. Now, for this one, I'm not going to distribute the 2 through here because those just go away when you divide out. So I got 2. This is going to be plus 4. This is cosine of 2x, and then plus 1. And then plus cosine of 4x. And now I'm just going to finish it. 2 plus 1, that gives you a 3. So this is going to be equals 3 plus 4 cosine 2x plus cosine of 4x. This one comes out as a nice no fraction type of a problem. But same process, nothing really changes. You're just working through here, trying to reduce these down, always substituting one of those formulas on that front page for one of these. Let's try this next one. Now this one says 4 sine squared x cosine squared x. So just like that last one, we want to start with that idea. We're going to start here. I'm going to replace. So this one says 1 minus cosine of 2x over 2. This one's going to say 1 plus cosine of 2x. All of that is over 2. And now, before I get too crazy, hopefully we see that 2 and 2 at the bottom, if I were to multiply those together, would give me a 4. Well, that's going to eliminate the 4 up here, so these are all going to go away, which is handy. That means we're only going to just double distribute here. We have 1. We're going to have a minus cosine 2x and a plus cosine 2x. Those just go away. And then we're going to square that so we get minus. This is cosine squared of 2x. This is what we have to this point. Now, we're going to have to do the same thing that we did before. We're going to substitute in again. So we're going to have 1. This is going to be minus. Then all of this is going to say 1 plus, this is going to be cosine of 2 times x, and all that is over 2. Substituting it in. Drop back down here, we're going to have 1, this is going to be minus. Simplifying this down a little bit, hopefully you see that this is going to be, I'm going to use my parenthesis here, this is 1/2. And then this is going to be plus, this is going to be cosine of 4x over 2. And then to simplify the rest of this, it's going to say 1 minus 1/2 minus cosine of 4x over 2. Our answer then could look one of a couple of different ways. This is 1/2, and it's going to be minus cosine of 4x over 2. It could probably be written as 1 minus cosine of 4x. All of that is over 2. A couple different ways you could write it. I don't think it really makes any difference. Just know that there are 2 and that you may be responsible for writing it one way or the other. Hopefully you guys see how that works in terms of power reducing. Some of them can be long, like that first one, and some of them are pretty quick, like this last one. It just really depends on the problem. This last part is talking about writing half-angle formulas. So our formulas for these. Well, we had the plus minus, depending on where we were at when we were finished. And then we have a 1 minus cosine x, and all that's over 2. So that was one of my formulas. The cosine formula, plus minus. This is 1 plus cosine of x, all that over 2. And then this last one, this is that one where you can put sine over cosine, or you can just write the answer to it. This one's going to say 1, for this one, 1 minus cosine x, all that is over sine x. Those were your half angle formulas. And now they want you to find the exact values of these. So using your half angle formula, that means this is going to say cosine of 30 degrees over 2, which means cosine of 30 degrees, we're in the first quadrant, we're using cosine, so it's going to be a positive answer. And 30 degrees, that makes this 1, this is going to be plus. This is 30 degrees is root 3 over 2. All that is over 2. Then it's just cleaning it up a little bit. So you're going to have square root of, this is 2 over 2 plus root 3 over 2. All that's over 2. That makes this the square root of, this is 2 plus root 3 over the 2 drops down to the other 2, makes this 4. We split this in half. This is going to say 2, the square root of 2 plus square root of 3. All of that is divided by 2 once we take the square root of the bottom. So this was the answer to the first one. Then the second one, we want to write this as a half angle. Well, that would be sine of 5 pi over 4 over 2. And then we're using 5 pi over 4. 5 pi over 4, or 5 pi over 8, we're in the second quadrant here. Sine is positive, so our answer is going to be positive. So how do we make this one work? Well, we would say it is 1 minus, this is going to be root 2 over 2, and all that's over 2. That makes this 2 minus root 2, and all that is over 4 when we actually simplify it. I'm just taking some steps here, break it into 2 pieces. This is 2 minus root 2, all under a radical, and over 2. And then we should have our solution to this one, if I'm not mistaken. The thing that I forgot here is that we're using cosine, not sine. Cosine is actually negative here, which makes this part right here negative, which makes this a plus, makes that a plus. That's the one. Sometimes when you're going along and you're going too fast and you say, oh, sine of 5 pi over 4, which is exactly what I did. So got to make sure you understand that these are in terms of cosines when you go to do these so that you don't use the wrong value. That one would have made a big difference in terms of the answer. And then the last one, if I were to just say, what's tangent or something, tangent of one of these two, just using the formula would find the other one. So hopefully you guys see that that's the case. Not really much more to this than the half angle parts of this. Just make sure that when you're doing the power reducing, you take your time. Don't try to jump ahead. Bring your questions to class with you and we will talk about them. See you next time. Bye.